Spider-inspired robot Can 3D print houses on the moon. A spider-shaped robot is changing everything we know about construction, and it's not stopping on Earth. Meet Charlotte, a groundbreaking machine that crawls, prints, and builds entire homes using 3D printing technology. Here's how this extraordinary invention could reshape life both on Earth and beyond. Bio-inspired design for a new era of construction. Charlotte is a spider-like, semi-autonomous robot designed to 3D print entire buildings using sustainable materials. Unlike traditional construction equipment, Charlotte's design takes inspiration from nature. Its creators, Crest Robotics and Earth-Built Technology, modeled the robot's movements and structure after the agility and adaptability of spiders. This unique form allows Charlotte to maneuver over uneven surfaces, straddle large areas, and print directly on complex terrains. The robot's multiple articulated legs provide both stability and flexibility, making it capable of working in environments where traditional machinery struggles. This bio-inspired approach gives Charlotte an edge in scenarios like lunar construction, where rough and unpredictable terrain demands more than wheels or tracks. It's an innovative fusion of robotics, artificial intelligence, and 3D printing technology aimed at redefining how humans build on Earth and beyond. The technology behind Charlotte. Charlotte combines advanced robotics with additive manufacturing, allowing it to fabricate entire structures from raw materials. Acting as a mobile 3D printer, the robot moves autonomously around a site, depositing layers of material to form walls, curves, and domes. At its core lies a modular printing system capable of switching between different materials depending on the environment. For Earth-based construction, Charlotte can use sustainable, low-carbon materials such as recycled aggregates or natural composites. For space applications, researchers envision it using in-situ resources, materials found directly on the moon, such as regolith, lunar soil. This adaptability is what makes Charlotte so revolutionary. Traditional 3D printers are often stationary and limited to producing walls or small modules. Charlotte, however, moves freely, adjusting its posture and angle as needed. It doesn't just print, it builds autonomously, with minimal human supervision. Rethinking the future of sustainable construction. One of Charlotte's greatest promises is sustainability. The construction industry is responsible for roughly 40% of global carbon emissions, largely due to energy-intensive materials like concrete and bricks. Each step, from mining raw materials to firing bricks in kilns, contributes to the carbon footprint. Earth-Built Technology and Crest Robotics aim to eliminate much of this through Charlotte's process. Instead of relying on pre-manufactured materials, the robot can print structures directly from raw or locally sourced materials. By minimizing transportation, processing, and waste, Charlotte could cut emissions significantly. According to Earth-Built co-founder Dr. Jan Golembiewski, even a simple brick has so many steps in its production, many of them very carbon-heavy. With Charlotte, raw materials go in, walls come out, all in one continuous process. The robot's ability to print entire homes from sustainable substances means greener cities could become a reality faster than ever. It represents not just technological progress, but an environmental necessity for a planet facing resource shortages and climate change. Solving the housing crisis through robotics. Charlotte's innovation is not just about futuristic tech, it's also about solving a very human problem: housing shortages. In Australia, the government aims to deliver 1.2 million new homes by 2029, yet the industry faces chronic labor shortages, supply chain delays, and escalating costs. Dr. Clyde Webster, founding director of Crest Robotics, argues that robotics is key to solving these challenges. Construction productivity has stagnated for decades, he said. We can't keep throwing people at the problem. We need technology that scales. Charlotte's design enables it to build homes faster and at lower cost than traditional methods. While a team of bricklayers might take weeks to complete a structure, Charlotte could do it in a fraction of the time. It's a tool that multiplies human capability, allowing smaller teams to manage larger projects. Experts like Dr. Nida Mohammadi, a researcher in project management and infrastructure at the University of Sydney, emphasize that automation can relieve pressure on the workforce. If you can offload repetitive, high-risk tasks to robotics, smaller teams can achieve a lot more. It's a force multiplier, she explained. This convergence of robotics and construction could reshape the industry's future, not replacing workers, but empowering them to focus on design, oversight, and innovation rather than manual, repetitive labor. Building beyond our planet. Perhaps the most ambitious aspect of Charlotte's development is its potential use in space. The same technology that allows it to build houses on Earth could one day construct habitats on the Moon. Earth-built technology has already begun discussions with space industry partners, including collaborators connected to NASA's Artemis program. This mission, set to return humans to the Moon by 2027, requires the development of sustainable, autonomous construction technologies that can operate without constant human input. Charlotte fits the bill perfectly. Its spider-like frame allows it to traverse uneven lunar terrain, while its 3D printing system can theoretically use lunar regolith as building material. This means astronauts wouldn't need to transport heavy construction materials from Earth, drastically reducing mission costs and increasing self-sufficiency. According to Dr. Webster, by developing Charlotte for extreme environments like space, we make solving problems here on Earth a lot easier. In other words, if a robot can build on the Moon, it can certainly handle Australia's suburban landscapes. The implications are profound. A technology that begins by printing affordable homes on Earth could one day be laying the foundations for human colonies beyond our planet. Government support and industry partnerships. Charlotte's rapid progress wouldn't be possible without strong institutional backing. The project has received financial support from the New South Wales Government's Space Plus program, which promotes technologies that bridge terrestrial and space applications. This initiative highlights the growing recognition that space innovation can directly benefit industries on Earth, particularly those struggling with efficiency and sustainability. With Australia aiming to expand its role in the global space economy, investments in crossover technologies like Charlotte are becoming more strategic. The unveiling of Charlotte at the International Astronautical Congress in Sydney drew attention from both the construction and aerospace sectors. Representatives from NASA, academic institutions, and major construction firms showed interest in how Charlotte's system could be adapted for various projects, from affordable housing to extraterrestrial infrastructure. Earth-built and Crest Robotics now plan to accelerate field testing, scaling from prototype demonstrations to full commercial applications. Within the next few years, they aim to showcase Charlotte printing complete housing units under real-world conditions. The promise of speed, efficiency, and affordability. Beyond its futuristic appeal, Charlotte addresses three key pain points in construction: time, cost, and labor. The robot's creators claim it can build the equivalent of over 100 bricklayers' output simultaneously. This speed doesn't just reduce project timelines, it also cuts down on costs related to labor and materials. Since Charlotte's process requires fewer intermediaries, no brick factories, no large transport fleets, and minimal human supervision, overall costs drop dramatically. This could make quality housing more affordable and accessible, especially in regions grappling with urban expansion or disaster recovery. For developing countries or remote areas, portable versions of Charlotte could provide a rapid response construction solution. Imagine a compact team deploying a fleet of these robots to print emergency shelters or medical centers after a natural disaster, within days instead of weeks. The future of construction. Charlotte's development signals a broader transformation in how we think about construction. Modern methods, such as additive manufacturing, 3D printing, robotics, and prefabrication, are beginning to merge, creating smarter, more responsive systems. Automation doesn't just make construction faster, it makes it safer. Robots like Charlotte can perform high-risk tasks, such as building in extreme temperatures, confined spaces, or hazardous terrains, keeping human workers out of danger. Moreover, the ability to integrate design flexibility means architects are no longer bound by traditional structural constraints. Charlotte can print organic shapes, curves, domes, and arches that mimic nature and improve energy efficiency. Buildings of the future could be not only stronger and greener, but also more beautiful. As urban populations grow and humanity sets its sights on other worlds, technologies like Charlotte will become central to our ability to build sustainably, efficiently, and intelligently. If you enjoyed this, look at Charlotte's incredible potential. Don't forget to like, subscribe, and turn on notifications for more amazing stories about innovation shaping our world and beyond.